Hey all, got a new topic for the AQA exam question walkthrough. So this is the first one for the buffer solutions topic. Hope you like the video, hope you find it helpful, and if you haven't already subscribed to the channel, I'd love you to do so. But as always, the link to the questions in the description of the video if you want to try it first. Okay, so make a start. So for part one, we've just got to calculate the concentration of the ethanoic acid in this buffer solution. So we just got to rearrange for the acid and sub in all the numbers. So the equation rearranges to that. So if we just look at the numbers, Ka we've been given is that 1.74 times 10 to the minus 5. The concentration of the ethanoate ion is 0.136. And the H plus concentration, well, we're going to get that from the pH. So we're going to do 10 to the minus 3.87 to convert the pH into the H plus concentration. Calculate the value comes out of that. So the three significant figures, the answer is 1.05 moles per decimeter cubed. Moving on to part two, so we've got a different buffer solution made of the same chemicals. So I'm going to refer to this system here to explain the question. So we're told the starting concentration of the acid is 0.26 moles per decimeter cubed and the ethanoate ions is 0.121. Then we're told that many moles, so notice these are concentrations whereas this is moles, that many moles of sodium hydroxide is added to 500 centimeters cubed of the buffer. Right, so the first thing I'm going to do is I'm going to convert these concentrations into moles. So all I did there was concentration times this volume, but remember that's got to be in decimeters cubed. So for the acid it was 0.26 times 0.5, so get 0.13. Likewise, 0.121 times 0.5 gets you 0.0605. Next thing we need to appreciate is when you put some sodium hydroxide into the buffer, what it's going to do is react with the H plus ions, so they're going to go down. So this system's going to shift over to the right to replace them. So the ethanoic acid is going to drop by the number of moles of sodium hydroxide, so it'll go down to 0.123. The moles of salt is going to go up by 7 times 10 to the minus 3 to 0.0675. So we've been asked to calculate the pH of the buffer after the addition of the sodium hydroxide. So we're going to bring in our acid over salt expression to get the H plus concentration for the buffer. Now these are moles, remember, but because they're all in the same volume, I can use the moles. I don't need to calculate the new concentrations. So the H plus concentration for this buffer after the addition of the sodium hydroxide is 3.17 times 10 to the minus 5. Obviously that's moles per decimeter cubed. And all I need to do is just minus log that and give my answer to 2 decimal places. So the pH of the buffer is 4.50. So well done if you got that one right.